Hi, in today's lesson we will solve absolute value inequalities, and before we get too in deep, we want to go ahead and rewrite these absolute value inequalities as a compound inequality. A compound inequality is two inequalities that are combined either with the word and or. An and inequality is when there's a less than or equal to symbol with the absolute value, and an or is when it's greater and greater than or equal to. Let's go ahead and look at the first one. We have absolute value of x minus 3 is greater than 5. An absolute value is the distance away from 0, and since there are two directions where you are away from 5, we do have two inequalities, as we learned in the earlier sections. So first inequality will be x minus 3 is greater than 5. And since it is greater than, it is an or problem. And the second one will be the negative of x minus 3. Notice it's in parentheses, is greater than 5. To simplify that, we do solve, and we do x minus 3 is greater than 5, or x minus 3 is, I'm just dividing it by negative 1, because it's technically negative 1. And since it is division by a negative number, the sign does flip, and 5 divided by negative 1 is negative 5. And this is our final answer. Now, the second one is absolute value of 1/3 x minus 7 is less than or equal to 51. So first one is as we see it. Since it is less than or equal to, this is an and problem, so both criteria have to be met. And it is a negative of 1/3 x minus 7 is less than or equal to 51. I do want you to focus on the fact that when we are writing these inequalities, that the absolute values are not part of our compound inequality. Final answer would be 1/3 x minus 7 is less than or equal to 51, and 1/3 x minus 7 is greater than or equal to negative 51. So once again, we solved that for 1/3 x minus 7 by dividing both sides by negative 1. Going further down, now we're actually going to solve the absolute value inequality, and once we solve them, we're going to graph the solutions. So let's go ahead and do the first one. The first one is absolute value of 3m plus 1 is greater than or equal to 16. So we're going to go ahead and write our two compound inequalities. The first one is 3m plus 1 is greater than or equal to 16. Since this is a greater than or equal to, we are going to say that this is a or problem, and the second one will be the negative of this. To solve means to solve each inequality. So we're going to go ahead and solve the first one. I'm going to subtract 1, and we get 3m is greater than or equal to 15 divided by 3 on both sides, and m is greater than or equal to 5. I'm not going to flip the sign, considering that I did not divide by a negative number, so that's one of the answers. I am going to bring this or down so that I remember that it's one or the other, and then solve the second one. I'm going to go ahead and get rid of the negative 1, which is technically there. And because I am dividing by a negative number, I will flip that sign to less than or equal to, and that's going to be negative 16. Subtract 1, and we are going to get 3m is less than or equal to negative 17, and m is less than or equal to negative 17/3 once we divide it by 3 on both sides. And this is the second part of it. When it comes to graphing the solution, you want to make sure you have a number line. And we're going to go ahead and put 0 in the middle. And we're going to put negative 17/3 on the left side towards the negatives, and 5 on the right side. Because the inequalities are both less than or equal to, or I'm sorry, that's greater than or equal to, or less than or equal to, we know that the dots have to be closed on both ends because of the equal to part of it. And we're going to go ahead and shade in the direction they asked. So M is greater than or equal to 5. So all numbers bigger than 5 will be to the right of the number line. And we're going to darken that. And anything that's less than negative 17/3 will be to the left. And then we're going to go ahead and shade that side. So that is the graph of the solution that we have found. And when you could see it, that it's going in both directions, one direction or the other. I want you to go ahead and try B on your own for a second. Once you have it in probably 10 seconds, I'm going to go ahead and have the answer up for you. So I'm going to pause this. You work on it. Once you're done, go ahead and open it and you'll see the answer. Hi everyone, we are back. I hope you solved the problem and you didn't have problems with it. If you look to the right on example 2B, you'll see my solution. So the first thing we did really quickly is rewrote the compound inequalities. And this is an and because it's less and. Solved each one receiving these solutions, and I wrote them together in the bottom. Once you solve them, then we did go ahead and graph. Looking at it, it says that W is less than 36. All numbers less than 36 are to the left of 36. And then for the second part, it says that W is greater than 4, and all numbers that are greater than 4 are to the right of 4. So therefore, the area that we highlighted, which is between 4 and 36, is the only answer because it has to be the combination of those answers, so where they both intersect. Looking at our last problem, it is a word problem. So this is a problem that actually requires an absolute value. It's a manufacturer has a 0.6 ounce tolerance for a bottle of salad dressing advertised at 16 ounces. Write and solve an absolute value inequality that describes the absolute value volumes for 16 ounce bottles. So because these salad dressings are kind of filled through machinery, there has to be an error allowed so that the person that is creating these products are not getting trouble for false advertisement. And for a salad dressing that's 16 ounce, this would be ideal because it says that it's 16 ounce, that the bottle's actually 16 ounce. But a manufacturer has a tolerance level of 0.6 ounce. What that means is it could go above 0.6 ounces, or it can go a little bit below 0.06 ounces and it would still be acceptable to be out in the supermarkets for us to buy. So if it's above, the highest level we can have is 16.6 ounces. And if it's below, the lowest level we can have is 15.4 ounces. Anything greater than that or more than that would not be acceptable when it comes to being bought in the supermarkets. So to write an absolute value inequality, first thing we're going to do is create a variable x, or any letter that you want. And for this letter x, we're going to say that this is the number of ounces for the salad dressing. And we're going to go ahead and take this x, which is the number of ounces for the salad dressing that we have, and subtract it from 16, which is the ideal, the average 16 ounces of salad dressing we would like. And we know that it has to be less than or equal to 0.6 or 0.6 ounces because that's the tolerance that we have. But we don't want to assume that it's always going to be less, since it can be greater than. We do know that we have to say it has to be absolute value of x minus 6, considering that we are going both in both directions. So we can be at 16.6 ounces, or we could be at 15.4 ounces, and the absolute value allows us to go in either direction of the 0, which in this case is technically 16 ounces. And that's our equation. Now it does say solve the absolute value inequality, and we're going to go ahead and solve it. So the first one will be x minus 16 is less than or equal to 0.6. Since it is less than, it is an and problem. And the second one will be the negative of this. Let's solve the first one. When we add 16 to the other side, we get x is greater than or equal to 16.6. And we're going to go ahead and divide it by a negative. I'm going to use a different color for that. And we have x minus 16 is now greater than or equal to negative 0.6. And we have x is now greater than or equal to 15.4. And if you look at these numbers carefully, hopefully you'll recognize them from our illustration. We knew that it has to be less than 16.6, and it has to be greater than or equal to 15.4 in order for us to have a salad dressing bottle be able to manufacture it into the stores. And that will be our answer. I hope today's lesson was easy. As always, if it was difficult, please go ahead and replay it and or write questions for us to answer in class. See you tomorrow.